Okay, we're rolling. Today's session is being recorded and it will be posted later onto the recorded presentations page of the MyTC Blackboard page for this particular class. And today we're going to cover the Module 1 Basic Device Configuration, the iOS commands. Because today's lab, we're going to configure one PCA and we're going to attach it to the switch and configure some things like the IP addresses for the switch and the PCA Windows Workstation, and be able to remotely configure it. So let's look at configuring a switch with the initial settings. Now, when a Cisco Ethernet switch turns on, it's very much like a desktop PC. It goes through a series of steps that does a power on self-test program that's stored in the read-only memory, just like a Windows desktop PC would. The power on self-test checks the electronic hardware, make sure that it's all okay, and then it loads. Step 2 is the switch is going to load his boot loader software. That's stored in read-only memory. That's not the iOS. That's a special program stored in ROM that we use to boot the flash memory that contains the iOS, and we also use it for disaster recovery, like if we need to reset the passwords. So the bootloader will initialize everything, initialize the memory mapping, etc. And then he's going to go to the flash file system that's installed in the Ethernet switch. This is similar to the hard disk drive on a Windows computer. So when a Windows computer boots up, he does the power on self-test, and then he goes and boots up usually the hard disk drive first. You can change it on a Windows computer. You can say, oh, I want to boot from the flash drive, or I want to boot from the CD-ROM drive. So by default in Cisco at the CCNA level, there are options, but we are always going to boot from the built-in flash drive. And finally, the flash drive is used because it's no moving parts. It's more reliable than a spinning rust hard disk drive, which could fail, because these switches are normally put in a wiring closet for over 10 years, and we don't want them to fail. Hard disk drive would probably fail before then. So the bootloader loads the iOS operating system, and then he turns control of the switch over to that. Just like your desktop PC loads the Windows operating system, he turns control over the Windows system, and Windows asks you to log in and do what you're going to do. If you want to change the default order, there is a command we can use called boot system flash. If we happen to have, this is like dual boot on a Windows machine, maybe you're dual booting Windows and Linux on your desktop PC. So we can put this command in, and if we have more than one operating system, more than one version of the iOS installed on the switch or on the router, we could tell it which one we want him to boot. So if you had if you were getting a new version from the vendor and you wanted to check it out, but you wanted to leave your old one on there in case it didn't work, you could use the boot system command to switch back and forth between the two of them. Now on the front of the switch, there's some lights. You guys are in the classroom. There's some lights that are present on the switches in the back of the room. There's a couple of lights lit. The system light is lit up, and it tells us that it's booted up. There's a redundant power supply LED. We don't have redundant power supplies or backup batteries for these systems. The port status light, the ports LEDs, the port lights can be either status mode, duplex mode, or speed mode. You can push that mode button, that blue mode button at the bottom, and you can switch it between these three things. By default, it's going to light up green whenever you plug in a device. The link light will come on after a moment. We don't have power over Ethernet present on these switches. Most production switches do have power over Ethernet because it's used to power Cisco telephones and Wi-Fi access points. If there is a crash, and there are two types of disasters that can occur with the switch. You can forget the password, or the person that knew the password left the company. No one knows the password. And the other possible disaster is the iOS file, the flash drive itself, gets corrupted. It can't boot anymore. So in the first case, we want to change the password to something we know. In the second case, we want to put a new replacement non-corrupted copy of the flash of the iOS file back in the flash memory. So to get the switch to boot up and not try to boot up from the flash memory, what we do is, now switches don't have switches. There's no switch on them. How do we turn them off and on again? If they're plugged into a power strip, you can turn the power strip off and on again. Otherwise, you can just pull the cord loose from the back of the switch for a second, plug it back in, and hold down that mode button at the bottom. And hold that down until the system LED turns amber and then solid green and then let go. And this is kind of like Windows has it. If you hold down the F5 key in Windows, you go into the recovery mode, safe boot. So you can do this if you need to do disaster recovery on the switch. Then you can go into the disaster recovery menu, the switch prompt, and change the password or get a new version of the iOS and copy it there. Now, we want to normally have remote access on the switch. So the only way to set the switch up initially is we have to plug in the console cable from a PC and set it up because it doesn't have any IP addresses yet. Once we get it configured, then we can log onto it. We can telnet to it or secure shell to it from anywhere that we have network connectivity to that switch. We're going to do something like that in the lab today. So we call this a switch virtual interface, or SVI. That's a remote access address. The command line VTY 015. You set it up and you tell it to allow access, and you set the password. We set the password Cisco for that in the academy classes. But we got to connect it first. So in the first part of the lab today, we're going to connect to the switch, make sure it's erased, do a step to make sure it can accept an IPv6 address, because in the lab today we're doing an IPv6 address, and then we'll put the IP addresses on it. So normally we configure the switch to have an IP address. By default, that's going to be VLAN 1. We're going to use VLAN 99 in the lab today. We're going to use the management. We're going to apply the management switch virtual interface, the IP address to the switch. We're just going to give it an IP address and a subnet mask. So in the lab today, when we create VLAN 99, it won't go up and up until I assign the port number to VLAN 99. That's just a Cisco peculiarity. And that last part is talking about these switches by default are only configured to run IP version 4. If you want to put an IP version 6 management address on it, we're going to do a step on there. And I will show you when I do the lab walkthrough after we finish the slideshow. I'll show you how that works. So here's some examples of commands. The global configuration mode, we go to the switch prompt. This switch has already been named S1. We're at the privileged exec mode. It's got the # prompt. We type the command configure terminal, config T, and we go into the configuration mode. The prompt changes to config, and we can do things like, for example, go into the interface VLAN 99. He's going to use that as a management interface in this example, and he's applied an IP address to it. He's also applied an IP version 6 address to it. And then he's given the command no shutdown, so that management interface is active. And then he types the command copy run start to save that configuration to the NVRAM so that it will be remembered if the switch is turned off and on again. It'll come back. The switch needs a default gateway. Now, routers are default gateways. They used to be called gateways, now they're called routers. So routers are the default gateways themselves. But all other devices, including employee desktop PCs and switches, need to have a default gateway configured if you want to connect to them across the router from another network. So in a Windows machine, we would configure this as the third line. We do the IP address, the subnet mask, the default gateway. On the switch, there's no graphical user configuration. We'll do it from a command line. We'll go and give the command IP default gateway, and that IP address is the IP address of the router port that this switch is going to connect to. No router in today's lab, just a switch. And then he saves the configuration. Step 3, let's verify this configuration. We can type show IP interface brief and show IPv6 interface brief, and it'll show us the address that's been configured. Now in the in the packet tracer version of this lab, the IP version 6 address is there, but you're not able to use this command because packet tracer does not do 100% of the switches and routers, only does about 95%. On our real devices here in the lab, it will work properly. That's like shown here. Okay, switch ports, full duplex communication, microsegmentation to the desktop. This means that you can transmit and receive at the same time. You're not connected to a hub. You're not sharing your PC within the devices. You've got the full bandwidth. So this is the best performance feature. So this is why we had to sign an acceptable use agreement working here. I'm not going to put a hub in my office because that would make things have collisions, and that would cause the IT guys to get a bunch of errors. Now, half duplex communication is like, it's like a CB radio where you have a push to talk machine, push to talk button on the microphone. If I push the button down, I can't hear you. You can't interrupt me. Full duplex communication is like a telephone. You can hear me, but I can hear you say something back to me while I'm talking, and you can interrupt me. So gigabit Ethernet and up 10 gigabit Ethernet are by default, they have to be full duplex. Standard old 10 megabit Ethernet and a few odd versions of, I have seen a fast Ethernet hub, but they're not they're very kind of rare to see. Most everything now is a switch, full duplex communication. So we're going to configure these switch ports. Now the electronics have gotten very good these days. They will automatically, when two devices are connected together, pick the highest possible speed of communication and whether you can go half duplex or full duplex. You can override those with a duplex and speed commands. Maybe if you're using an older switch, or you're using a Cisco switch at one end of the link and another manufacturer's switch on the other end of the link, you might need to manually configure these. But normally auto negotiation works quite well. So we can check this with show interfaces and see if we got a bunch of late collision errors or something like that in the list. It may be a half duplex, full duplex mismatch on both ends of the wire. Fiber optic cables, they are always full duplex by default. There's no such thing as half duplex with fiber optic cable. So if we need to configure, we have two switches connected to here. Normally auto configuration is going to work just great, but maybe it's a really old switch, or maybe it's a mixture of different vendor switches. So we can go to the configuration mode on our Cisco switch and say, force it to be duplex full or duplex half, force it to be speed 100, speed 1000, and then save that to the running configuration to fix our errors. Auto MDIX is a feature that's been present in most all desktop PCs and switches and routers for the past 10 or 15 years. Our cable types that we learned straight through cross connect, our old requirement that if we connected a switch to a switch, we had to use a cross connect cable, or we connected a router to a router, or a PC to a PC, you had to use a special crossover cable where the wires were swapped. Modern devices automatically, no matter whether you plug in a straight through cable or a cross connect cable, it's going to work just great. He's going to switch the transistors over and make that work for us. So auto MDIX is the default. And we should use this for all new devices. If we have a really old device, we might need to change that. So here are some switch verification commands. The show commands in Cisco are used to check various things, like show the status of the interfaces, see how many errors there are, and so forth. So show running command shows us the line by line lines of code that have been typed into the iOS to configure the switch. So by this sample output we have here, we can see that the management interface has been set to VLAN 99 instead of the default number 1. And he's been set to this particular 172.16 IP address. He's also got a IP version 6 address. Show interfaces shows us, he's just shown a little bit of it here, but he shows you, well, it's up and up. That means we type the we did type the no shutdown command, or on a switch port, it goes up and up by itself, and wires plugged into it. We can see what the MAC address is. We can see what the bandwidth is. And further down, not shown on this screen, is if there's any errors, he'll show you the types of errors that exist. You might have a bad wire, a faulty, twisted, kinked wire, or something of that nature. Now, at the network access layer, we're going to check to see, we use show interfaces to look for problems with our media. So if it's up and up, that's good. The two devices are communicating with each other. If it's not up and up, maybe it says administratively down. Someone type shutdown to shut down the port. Maybe it says up and down. There's some mismatch at layer 2. The first up is layer 1, physical layer. The second up is the data link layer. So if there's not up and up and connected, there's either a software configuration issue or there's a physical hardware issue with the wire. Show interfaces will show us, here's the one that shows all the statistics. So those parts that are in orange at the bottom, 0 errors, a few errors, single digit, double digit errors, that's nothing to worry about. When you see thousands or millions of errors, you've got some type of wiring fault, or you've got some sort of mismatch error that's causing those errors. So some errors are not that severe, but it can cause the network to not perform as well as it could. So this chart lists some problems like runts that are Ethernet frames that are too small. They're supposed to be 64 bytes at least. Could be a collision fragment. Giants, any Ethernet fragment that's greater than 1500 characters is a giant. CRC errors, when an Ethernet frame is transmitted, he sends the frame check sequence, which is a cyclic redundancy checksum CRC, and the receiving workstation recalculates it, and if it's not the same, it's an error. He drops the frame. It was one of the bits got corrupted. That's his way of finding errors. So runt frames, less than 64 bytes. Giant frames, bigger than 1500. Now, sometimes in some data centers, they purposely set the frames to be 10,000 bits, so they can get faster data transmission in data centers with lots of errors. So if it's a CRC error, it's usually a wiring error. Collisions and late collisions, if it's a hub, we get collisions all the time. Ethernet was designed to handle collisions and recover from them, just retransmit the data. If it's a full duplex wire, though, which we don't want to use hubs anymore, hubs are dumb. Do not be in the hub club. We want to use smart switches. So if it's a full duplex communication with a switch and no one's put a hub in there somewhere, you should never see collisions. Late collision is if you make the wire too long. Ethernet cable wiring, twisted pair cables are only allowed to be about 328 feet. If you make it much longer than that, you can get late collisions. So to troubleshoot network access layer issues, we're going to look at the show interface command and see, is the interface up and up? Well, if it's up and up, let's look at the check for, maybe we have electromagnetic interference or radio frequency interference, a kinked cable, something of that nature that's causing problems. If it won't even come up and up, the cable's not plugged in, it's the wrong cable type. We can check to make sure that everything's set properly on both sides. Now let's look about remote access. There's two types of remote access. By default, we're going to use Telnet, which you remember from your fundamentals class, uses port 23. And Telnet has a problem in that it's totally unencrypted. So I can run, he's got a picture here on the screen of the Wireshark program, which is the free open source program. You can analyze the network. So you can read the guy's password with Telnet. You can read his name, read the password, read any data he's sending back and forth. So Telnet's okay if we're in a lab here, if you're in a sandbox, your laboratory, something like that, where people in the outside world can't get to it, you can get away with it. But best practice is don't use Telnet in a production network. Use secure shell, which encrypts all the traffic. Kind of like when you go to a web page and you go to the bank and you transfer money, or you go to Amazon and you put your credit card number in. You don't want that number to be available for other people to steal your credit card number. That's all encrypted traffic, HTTPS encrypted traffic. So secure shell uses port 22, and it encrypts everything. It uses a public-private key exchange scheme, which allows you to encrypt the traffic, and no one can see it but the person who should be receiving it. All right, please come in and choose a seat that doesn't have an X on it. We're recording the PowerPoint presentation, and then we'll get you guys hooked up. Try to log in with your existing web advisor information. Anywhere that doesn't have X. Now, some older switches do not support secure shell because secure shell requires encryption version of the iOS. You can tell if it's an encrypted version of iOS, it'll have a letter K in it, K9. Doesn't mean dog. It means it supports encryption. Ours do. So you can tell that by typing in the show version. In this case, on the print, it says K9-M at the end of the file name. This is a file name that supports encryption. If it doesn't support encryption, you ain't gonna be able to run SSH. So we had some old Cisco switches in here from 15 years ago. They did not support encryption, but we got newer switches now. So make sure that secure shell is supported. Step one, you can do show version and make sure it's got a K9, or you can type show IP SSH at the prompt. If it doesn't have SSH, it's going to treat it as an unsupported command. Step two, we have to configure a domain name. On a laboratory, it can be anything. Cisco.com, your last name, anything you like. Step three is we're going to generate our key pairs. So we're going to type a command that generates a public and a private key pair, and these keys are used to encrypt and decrypt the secret information you don't want other people to see. Then you're going to figure in step four, you're going to make a username. So someone can log in with their username and password that they know and make sure they're the person that's authorized to use it. Then we'll go and configure the VTY lines to use secure shell instead of Telnet. You can configure to use Telnet and secure shell, but that defeats the whole purpose of secure shell. Somebody could come up with Telnet. So let's go to a PC and use PuTTY, or in the case of here in the classroom, we use TerraTerm, and connect to a secure shell server. So in this case, the PC, he types, he's just the password admin, and then he uses enable, and he gets to the privileged exec mode. And when you first connect to a secure shell device with TerraTerm here, it's going to prompt you. You're going to pop up that says, accept this key. And you put a bunch of weird hexadecimal characters up on the screen and just click OK. You'll only have to do that the first time. So if I type show IP SSH, it's going to either say, it'll give you this message, or if it's not enabled, you'll get a message that this iOS doesn't have it. It's just, I don't understand this command. It's not an understood command. I'll do a separate packet tracer video for this later that shows you how to do this lab on that we're going to do on packet tracer, because on packet tracer there's another switch you have to pick that has the IP iOS 15 on it that you can do SSH and IP version 6. Routers and switches. The great thing about Cisco is that once you learn the iOS on the switch, you know it on the router. You know it on every device that Cisco makes. It's got all that stuff, so you don't have to learn one command language for one device, another command language for a firewall, another command language for a router. It's all the exact same syntax. So if we're using a router, we're going to do the same thing. We're going to go to configure terminal. We're going to give it a host name. We're going to put in enable secret class. We're going to put in passwords. We're going to do service password encryption there, so the passwords are hidden on the screen. Someone can't look over my shoulder and see the settings. So on a router, the banner message of the day is a recommended thing that you can put. So what is you going to say there? What your company lawyers tell you to say. They'll say something like, my favorite expression is from the old Lost in Space thing, warning Will Robinson. The robot always says, warning Will Robinson. I put that. But when you work for a company, they'll have something there that your lawyers told you to say, like unauthorized access not allowed. If you disagree, log off now. They'll put a nasty gram on there. So you can put whatever you like in there when you do it in the class. And then once you make the change, put it in. Now, dual stack is a term that means we have been using IP version 4, and about the turn of the century, we started pushing out this new thing it was called IP next generation, and now we know it as IP version 6. So we should, on a going forward basis, like Dilbert said, thank you for ruling out time travel, pointing here at boss, we're going to go on a going forward basis. We're going to migrate everything over to IP version 6. But for a while, we're going to be running a mixture of IP version 4 and IP version 6 things. So we're going to configure, in our lab today, we're going to configure the switch to be IP version 4 and IP version 6. If you look on your PC in here and you type ipconfig at the command prompt, you're going to see it has an IP version 4 address, has an IP version 6 address. So we can configure these on the router so they support communication between IP4 and IP version 6. So we have our generation 1 integrated service routers here. They have 2 gigabit ports. They have a WAN interface card. An interface can be configured with one IP address, and you can configure it with more than one, because it's like, what are there, 6 different times of IP version 6 addresses? Anywhere there's not an X. Now, by default on routers, all the interfaces are shut down, and you must configure them with an IP address and then type no shutdown, and plug a wire in. On switches, the only thing that's shut down by default is the SVI, the VLAN address, the switch management address. You have to do no shutdown on that. All the 24 ports will come up automatically, because 75% of these switches that ship into business are never configured. They just put them in the closet and they plug things into them. They don't want to spend $300 an hour for a Cisco hacker to come and set them up. So, but in bigger organizations like this, we manage the switches. We assign VLANs. We give an IP address to the switch so we can log into it from a real location. We don't have to run down to the switch and plug in a console port to it. So on a router, though, all the ports are shut down. We got to do a no shutdown to use them. And we're allowed to use a description keyword when you configure an interface port. You can put a description that says, this goes to the dean's computer. Under no circumstances allow this port to go down. Because the dean my dean was in the Marines for 30 years. He ain't taking no guff. You can put whatever. It's like a comment. If you've done programming languages, you put a comment line. It can be anything you want to. It's just to document the program. So on a router, we would configure the ports with IP addresses, IP4 and IP version 6 addresses. So here he's configured at serial ports and Ethernet ports, and he's used the no shutdown command 3 times to bring these ports out. Loopback ports. The most famous loopback port in the world is 127.0. Thank you. 127.0.0.1. It's on all desktop machines. It doesn't matter whether it's Microsoft Windows or Mac OS X or Linux. You can always type, even if you're not plugged into a network, you can type ping 127.0.0.1, and that verifies the TCP/IP checkmark box is in the network control panel. If you uncheck that, it takes out the IP, takes out the network code. You won't work. So that's used to check, just to make sure that you're configured and ready to plug into the network. So sometimes we use loopback ports on routers and switches for things like, oh, when we do the OSPF stuff and after spring break in that course, we may use a loopback port for that. Or if you're doing a laboratory, you only have 2 Ethernet ports. What if you need a 3rd one to test something, like a fake server? You can just make up a loopback port and type it in there, and you can ping it from another device. So I could go to the router and say router config interface loopback 1, and then give it an IP address. The weird thing about loopback ports is you don't have to type no shutdown. They're already up and up automatically. Now you can do a no shutdown if you want to, and then do a no shutdown, bring them up. So as soon as you create a loopback address, it's going to pop up as up and up. You don't have to do no shutdown. You can type no shutdown on it. It'll still stay up and up. Okay, so here's similar to what we saw before. We can look at an interface. We can do show. My favorite command, show IP interface brief, which can be abbreviated as SHIPINTB, for short. If you have a problem with your lab, and I come up to you, I'm going to have you type 2 commands. The first thing I'm going to you type is show IP interface brief. And I'll say, oh, you forgot to type no shutdown. It's administratively done. Oh, look, you fat fingered it. You type 129 instead of 192. So I can your eye will get used to it. You won't see it, but somebody else's eye will catch it. We can use show routing config, check the configuration of the switch or the router, and then show IP route. If the route is not in the routing table, you can't transfer a packet to that. You won't be able to handle it. We can check the interface status with show IP interface brief. It looks like this. Show IPv6 interface brief. All of the newer devices support IP version 6. So most of the commands that say like show IP route, that's IPv4. If I want to show IPv6 routing, I show IPv6 route. So almost all commands that say show IP something, you type show IPv6 something, and you'll get the IPv6 version of it.
What's the password?
Sorry?
Password to the.
It's your web advisor. It's your web, the one you logged into Web Advisor.
Okay.
Hang loose and I'll help you get to it here. Let's finish. I'm taping this right now for the people that are here. What's your last name? You've been with me before. What's your last name?
Gundo, Ngundo.
Okay, I got you. Arnold. You go by Arnold?
Yep.
Okay. IPv6 addresses. We can type show IPv6 interface, and we can see, there's like several different types of IPv6 address. We're going to work with the global unicast 2001 DB8 in the lab, and we're going to use the link local address, the FE80:::, address. So we can check this show running configuration. There's a shortcut command. If you type show run, normally you get the whole guacamole. It's like 3 or 4 pages. But you can zoom into one particular section. He's typed show running config interface gigabit. It's only going to show the lines that are about that interface. So you can zoom into that particular section. Now, to check routes on a router, our switches are not smart layer 3 switches. They don't have routes in them. But on a router, you type show IP route or show IPv6 route, and that shows you all the routes that network knows about, either directly connected routes that are his own routes or routes he has been told about by another router, like with a dynamic routing protocol like OSPF. We can filter a show command. We can type show something, and it may be pages and pages. So we can use that pipeline character, and then it's like show run pipeline character I for include VTY, and they'll just show those lines that have the character VTY in it, instead of having to look through several lines. This is in Windows. If you're at the Windows prompt and you want to repeat a command you typed at the command prompt, just tap the up arrow key and it'll roll back through all the commands you typed. And you can repeat that command. So this is on the router and the switches too. We can use the up arrow key and pull back a previous command instead of having to retype it all over again. Okay, let's see. Is that it? Okay, hang on just a second. I'm going to stop recording. You can let me stop. Here we go. Stop recording.